Hi guys, there were a couple of questions about dealing with matrix multiplication. Let me just quickly explain. First of all, to multiply two matrices, let's suppose you have a matrix A and a matrix B. To be able to multiply them, let's suppose the size of the matrix A is m by n. Remember, m is the number of rows, n is the number of columns of matrix A. And then let's suppose the size of B is n by p. So this is it. The only way you can multiply matrix A and B is that the number of columns of the matrix A must be the same as the number of rows of the matrix B. Okay, so these two numbers must always be the same. Otherwise, you cannot. That's why sometimes they ask you if it's possible to multiply. So if these two numbers are not the same, you can. Okay. Now the way multiplication works. Oh, by the way, when you do multiply, when it's possible, actually the size of the final answer will be m by p. So matrix A times B will actually turn out to be m by p. Okay, so the two outside numbers will give you the actual size of the product, if it's possible. And the way you know if it's possible, if those two numbers are the same. The number of columns of the first matrix must be the same as the number of rows of the second. Okay, let me see if I can do a quick example, because I think she wanted to see an example of a matrix multiplication. So I'm just going to do a 2 by 2. So let's suppose you have matrix A is negative 1, 2, 0, 3. Let's suppose the matrix B is 3, negative 2, 1, 4. So let's suppose you have these two matrices. So first of all, it is possible because matrix A is 2 by 2. You have 2 rows, 2 columns, and also matrix B is 2 by 2. So as we said, as long as these two numbers, those two doesn't matter, but these two in the middle must be the same. And now the way it works is actually very easy. You're just going to go row times the column, okay? So you're going to multiply the first row by the first column. And the way you do that, you're going to go this negative 1 times 3 plus 2 times 1. So let me go ahead and work it, the product. And don't forget, the answer should be also 2 by 2. Remember, because the two outside numbers will give you the size of the product. So we're going to go negative 1 times 3. So it's going to be first row times first column. And the way you do that, you go negative 1 times 3 and then plus 2 times 1. Okay, that's going to be actually your first entry of the first row. To get the second entry, we're going to go first row times second column. So it's going to be negative 1 times negative 2 and then plus 2 times 4. And that actually gives you, we're going to have to work that out, but that's your first row. And to get the second row, this time you're going to go to second row of the first matrix times the first column. The same way, 0 times 3 plus 3 times 1. And then your last entry is going to be second row times second column, which is 0 times negative 2. 0 times negative 2 plus 3 times 4. And the last step is just to work your arithmetic here. Let's see if we can reduce. This is negative 3 plus 2, which becomes negative 1. So there's your first entry. Negative 1 times negative 2 is positive 2. 2 times 4 is 8. And 8 plus 2 becomes 10. And there's your first row of the product. 0 plus 3, of course, will remain as 3. And 0 plus 12 will remain as 12. So there is your product of A times B for these two matrices A and B. So there was a question about, one of the questions I think that was about whether the inverses versus the matrices, actually you can divide them. So you can multiply matrices, but you cannot divide. Okay, so division of matrices is not, there is something called inverse of a matrix. So if you have a matrix A, there is A inverse. So I'm going to actually do a quick example of find the inverse also, but yeah, but there is no division. I think the young lady who asked about it asked about, can you divide matrices? And the answer is no. The only thing you can do is actually multiply them. You can add them, you can subtract them, you can multiply them, but there is no division for matrices. The closest thing we can do, of course, is talk about the inverse of a matrix. Also, the identity matrix, there was a question about identity matrix. And so, what is the identity matrix? So identity matrix, now this is different size. It could be a 2 by 2 identity, 3 by 3. So anytime you have ones along your diagonal and zeros everywhere else in your matrix, that's called the identity matrix, okay? So this is for a 2 by 2. Now 3 by 3, of course, will be the same thing, except you have 3 rows and 3 columns. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now one of the characteristics of an identity matrix is if, and by the way, excuse me, usually we use capital I to represent identity matrix, depends on the size. Of course, this is a 2 by 2 identity matrix, and that's a 3 by 3 identity matrix, okay? Now, if you multiply any matrix by identity matrix, it's just like multiplying by 1, okay? Identity matrix kind of play a role of 1. You get the matrix back. So always remember, any matrix times identity matrix will be the matrix. The same thing, if you multiply identity matrix by any matrix, again, you get the same thing back, okay? So this is always going to happen when you multiply matrix by identity matrix. Let me show you also one quick inverse of, if I had to find an inverse of a matrix. That one is a little longer process. Again, I do suggest, I know right now your exam is coming up at 2. I wish you would have asked this question a little bit earlier, but it's okay. There's also some more YouTube videos. Just go to YouTube and type in inverse of a matrix, okay? There are plenty more videos that can, show you. So I'm just going to do a quick 2 by 2. Because I don't think I have enough room on here to show you 3 by 3. But again, there are lots of YouTube videos on also 3 by 3. Okay, so let's suppose the matrix A is -1, 2, 1, 3, and we want to find A inverse. Okay, so this is inverse. Now, what we have to do, of course, to get the inverse of any matrix, you're going to have to form what's called augmented matrix. So you're going to put your matrix, and then you're going to put dotted line, and then you're going to add the identity matrix. Remember the identity matrix? Now, your job is to go from this matrix into, now you're going to have to kind of flip it. Now you're going to make this to be the identity. On the left-hand side, you want the identity matrix to show up, and on the right-hand side, whatever shows up, so of course you're going to have 4 entries, that is going to be your inverse, okay? So the inverse is going to be those formed by those 4 numbers. But you have to take your augmented matrix, change it to that, okay? So the way you do that, of course, is you have to make the first entry 1. So this is -1. So remember, there are certain operations you're allowed to do. You can multiply a row by a number. So in this case, you multiply by -1 to make this 1, right? And then you can also multiply a row by a number added to another row. So once you make this 1, to make this 0, of course, you're just going to multiply. Actually, right now, you can actually add these 2 rows and make that 0, because -1 plus 1 becomes 0. So the whole point is you can multiply a row by a number. You can multiply a row by a number added to another row, replace it by that row, and all those are allowed. These are called elementary row operations. So at the end of the day, whatever 4 numbers you get after you make this 4 numbers become 1, 0, 1. Again, you can add those 2, that's your 0. Multiply by -1, there's your 1. Now, once you make that 0, you can also make this one 1, because the fact that you can multiply that one by -3. And so basically the idea is make this 1, make this 0, make that 1, and then make that 0, okay? So using the elementary row operations. Anyway, there's more examples in the book, and also you can, I'm sure, check more. And I believe I did actually put a video earlier, maybe a week ago or a couple of weeks ago, about inverses from this section. So please go back and check some of those videos that I put for you from YouTube, and hopefully that helps. Thank you.